Okay, so welcome back to another tutorial on arrays. Now, as we discussed the basics in the previous one, we'll be dealing with arrays in a great bit of detail in this tutorial. So let's do a 10-second revision, whatever we did in the previous one. We made something called a single dimensional array. Now, there are basically three types of arrays. We have single dimensional, which we dealt with in the previous one. We have two-dimensional arrays, and we have something called as a multi-dimensional array, right? So in this tutorial we'll be talking about two-dimensional and multi-dimensional ones. So let's get started. Now what what is the real world thing which we represent in 2D, right? We all know what two-dimensional is. We have an x-axis and a y-axis in that case. So what is the mathematical equivalent of a two-dimensional figure? Yeah, you guessed it right. It's something called a matrix, right? We have something called a matrix, which basically is two values. We have rows and we have columns. So this is basically the syntax of a two-dimensional array. We have the number of rows here and we have the number of columns here. So that is how matrices are represented in C. Again, we need to give it a name, so we'll just call it matrix 1. So this is basically what a two-dimensional array looks like. We have 5 rows here and we have 4 columns here, which again gives it a total size of 5 into 4, which is 20 elements, which reserves 2 into 20, that is 40 bytes of memory for this particular array called matrix 1, right? So now let's do this. We'll read a matrix, or say we'll read two matrices and we'll add them. So that's what we'll be doing in this one. So let's make another array here with another matrix. Now, as we know, the condition for adding two matrices is that the number of rows and columns should be equal, right? So we'll be needing two variables here because we are dealing with a two-dimensional array for the loop. So again, let's go ahead and make a for loop real quick. We have 5 rows, so I'll go with I plus plus here. Now inside the for loop, we'll make another for loop, a nested one, because again here we have to use j. Let me quickly finish up the syntax, so I'll explain you what we are doing exactly. And here we'll be reading the values, so percentage d and ampersand matrix 1 I and j. Perfect. Now let me quickly explain you what I wrote here. With the very first time when this loop starts, the I value will be 0. So when the I value is 0, the j loop will again run 4 times, right? Then the I value will be incremented to 1 and again the j loop will run 4 times. So basically this I loop will run 5 times in total because we have 5 rows here, and this j loop will run 5 into 4, that is 20 times in total, because we need to take 20 values, right? We need to read 20 values and store it in the matrix. Again, the reason for using ij here is that when the value of I is 0, we'll have 4 values of j, right, from 0 to 3. Then again when the value of I is 1, we'll have 4 values of j again. So this will keep repeating for 5 times until we are done reading 20 elements. So let's go ahead and copy this and paste it again for the another matrix as well. So I'll quickly change the name here to matrix 2, and let's add a message for the user here telling them what they exactly need to do. So we'll say enter the elements, okay, of the first matrix, and we'll read the elements. Again here we'll say enter the elements for the second matrix, right? And finally what we'll be doing is we'll be adding these two matrices and we'll be displaying the sum. And again we'll try to display it in a matrix format, which is a 2D format. I'll tell you guys how in just a while. So now we need another loop for adding these, right, because we need to perform 20 addition operations here. So we'll again start with 0, we'll go to 5, we'll increment I, again we'll nest this loop with the value of j, right? And here we'll, now since we need to add these matrices, we need another matrix where we'll store the results. So let's go ahead and make another matrix real quick. Now again the size of the resultant matrix also should be the same, that is 5 rows and 4 columns, because matrix addition is dependent on rows and columns only, right? So the case is different with multiplication. So when you do multiplication, you need to make sure that the number of rows of the first matrix is equal to the number of columns of the second one, right? Okay, so now we'll be adding those values. So we'll say matrix 3 is equal to, or we'll have to give ij here. We'll say matrix 3 ij is equal to matrix 1 ij plus matrix 2 ij. There we go, semicolon at the end. Let me make sure everything is correct. Okay, we named it matrix, so let's go ahead and change the name to matrix 3. Alright, so now we have the resultant matrix here. Now we need to display it back, so again we need this loop. So I'll quickly copy it here, and instead of adding, we need to go ahead and display the values of matrix 3. Now I'll tell you guys a quick trick to display it in a 2D format. So again, in J's loop body, what we are doing is we are displaying the elements of the entire row, right? And we'll be changing to the next row in the I loop. What I mean is that for the first row, we'll be displaying the entire elements in this loop. Then again, for the second row, we'll be displaying the elements inside it, right? So here we'll basically print the elements, and we'll add a new line in the I's body. So here we'll say matrix 3 and I and J. There we go. And outside the J's body, but before the closing of the I loop, we'll add a new line. So we'll just say printf /n, and that should add a new line. Alright, so let me make sure I didn't mess anything up. Okay, everything looks good. So let's go ahead and run this and see if it actually runs. Okay. Alright, we missed the semicolon here. Right, so enter the elements of the first matrix. Now again, matrix elements are entered row wise. So I'll say 2, 3, 4, 5, 6, 7, 8, 9. I need to give it a number of elements because we entered a 5 by 4 matrix. Right, so just me randomly add some elements, and for the second matrix as well. Right, so that is the resultant matrix. Right now, as you can see, it has been represented in the actual matrix form. This is the first row, this is the second row, this is the third row. So that happened because we went to new line after the ending of each row, right? The row was printed here, and after that, before printing of the second row, we went ahead and we made a new line character, right? So that is how this 2D sort of a representation is done. So that is it about the two-dimensional arrays. Now there is actually no limit to dimensions. You can have a 3D array or a 4D array. The actual size has not been specified, and C does support arrays up to 10 dimensions. I read that somewhere. I did not try it out actually. But again, if you make a 3 by 3 array, what happens is that the total number of elements is 5 into 4 into 3, which is equal to 60 elements. Right, so that is how it goes. And again, you need to add 3 loops here for reading the 3-dimensional array, and the number of loops should be equal to the number of dimensions you are having. So that was all about arrays. Now there is only one thing left, which is something called a character array or a string, and I'll be telling you guys about that in the next one. So thank you guys for watching. I'll see you guys in the next one.